So let's make our panel borders. So I'm going to put down a split node. And we want to split by these small panels. So let's come to find a single pass. Make sure we invert that. Here we go. Find one that has actually a large panel. Now I'm just going to quickly put down a merge here. Cool. So off of here, let's put down an attribute promote. And I want to promote our height, width, and border to a point attribute. And I'm also going to put down another promote. And promote our normal. I'm going to change name. We don't want to delete the original. Panel direction. Panel dir. And we'll have that stored. Okay. I'm going to put down a poly frame. And on this, I'm going to switch it over to primitive centroid. I'm going to get the tangent and set that as our new normal. So we should have normals that will be pointing directly towards the center. So we're going to use those to move points around and make our border. Okay. Okay, now let's get the sort of direction these are facing. Because we can easily move these up and down, so we just want a straight horizontal direction. So to do that, we'll go @n.y equals 0, so set y to 0, and then go @n equals normalize @n. And you can see we've got a direction that these are facing. Set direction okay. Create another angle. Check for border Y. And we're just going to run over point 0 and we go if you at border dot y equals 0. Remove this primitive. So input 0, primitive 0, remove points as well. That's what that final one does. And then come over here, copy that. And convert that to X. Let's just tidy this up a little bit real quick. then switch this over to border dot x. Okay. We need another angle. That's going to be side A. And this is going to be over points 0 and 3. So this side. And this is why we did this sorting up here, so we can move these points consistently for every single panel. So at P plus equal at N, and then in brackets at width minus u at border dot x divided by 2. And then at p dot y equals, and then we need to see if it is 0.0. If it is 0.0, you might be able to hear my cat snoring in the background. Sorry about that. We can go, so if it is 0.0 at p dot y minus in brackets u at border dot y divided by 2. That doesn't really need to be in brackets, but sometimes I do it just for my own peace of mind. Otherwise, it's p dot y plus u at border dot y divided by 2. I forgot to put a times in there. Okay, and that should give us that. And then I'm just going to copy this over for our other side. And this wants to run over points 1 and 2. And then you can see it's already moved it across. We just need to change this to be, if that's 0.1, we do this. And what this line is doing, you won't see it on this one, but this would move this point down. So it, when we have a top border, they connect nicely. Okay, now we need to do a very similar thing over on this side. And this will be our top. So go at p dot y plus equal if at height minus u at border dot y divided by 2. So all these are half because we know the overall border size and we're making a border at top and bottom, so it needs to be half. And p plus equal and n, which is our direction we're moving horizontally, times u at border dot x divided by 2. And this needs to run over points 2 and 3, which are our bottom points. And this will error out because there's no points coming into it, but that's okay. And this should be our bottom one. And 0.0 and 1. And then we should just need to change this to minus instead of plus equal, minus equals instead. So you want to move the top down. Then we need to merge all these together. Put in a fuse. And then fix our normals and merge those back in. And if we turn off single pass now, it should have given us all of our borders. See, we have a lot more horizontal borders because most of our buildings have been sort of fitted to a range that'll match our modules. But you can see we've got some here, and the important thing is we've got no bits going across diagonally or anything like that because we've done our point sorting correctly. And in these bits, this is where we'll add our point grids to copy our modules on, and that's what we'll do in the next video, is make those grids.